Morning, everyone. Am I audible to you? Just tell me. Okay, so I am audible. So now today we are going to start gravitation. This chapter is kind of similar. The basic phenomena were similar to the electrostatics. That Coulomb's force is similar to the gravitational force. Electric field is similar to the gravitational field. So potential, everything is kind of similar. So we can easily understand this chapter and very quickly we can do this. So let's start our gravitational chapter. I hope you all are good and all are studying very well. Moving to the first slide, what we are going to study in this chapter that's mentioned here. Okay. Okay, so let's start with gravitation law. Listen to me. What is gravitational law? Let's suppose there are two masses. One is M1, another is M2. And they are separated by a certain distance r. Then Newton says that the force between them, F is equal to G into product of masses divided by the separation square. This is Newton's law of gravitation. That's a very simple thing and everyone should know this. Now, few important things about this relation. What is G here? Everybody knows that G is universal gravitational constant. I'm not going to write let's suppose I'm writing gravitational constant. Okay. Now it has certain values. Again, one thing is this R is the separation of the two masses, and this R is always considered from the center to center. This distance is considered from center to center. Again, one more thing, the direction of this force is a vector quantity, so it must have a direction, and gravitational force is always attractive in nature. So what you can write, always attractive. Now, what is the meaning of this? What is the meaning of this? That whenever a mass, like suppose M1 is there, it will try to attract M2 and M2 will try to attract M1. Let's suppose this is point A and this is at point B. So if I say what will be the direction of gravitational force? Which gravitational force? FAB. What is the meaning of FAB? How you will pronounce it? It will be pronounced at force on A due to B. Can you understand it? This relation is asking us calculate force on this A due to which? Due to B. So this is the source and this is the object at which force is to be executed. Force is acting. So what you can say, this force is always attractive. That means B will try to attract and you will put an arrow like that. This is the direction of FAB. Can you identify FAB? Or in short, if I say, if it is mentioned FAB, then direction should be A to B in this direction. And if it is mentioned FBA, direction should be from B to A. Tell me one thing, is direction concept is clear? How to get the direction of gravitational force? If it is clear, then it's very simple. Now, few more things about this. Like in electrostatics, what you have seen, I think you remember that if we place some medium between the two charges, another than the free space, then the force decreases. But here, the force will remain constant. It's independent of the medium between the two masses. Is the statement clear? Write it down. This gravitational force is independent of the medium between the two masses, like this. Okay, I have written some punchlines for you. It's mentioned, already mentioned. Gravitational force is independent of medium between bodies. One thing is clear. Second statement is again very important. It is a conservative force. Do you know what is conservative force or what are conservative forces? Tell me yes or no. It is valid for point masses. It is not valid for large masses. It may be it. We can make it possible. We can make it valid in some cases. And another, it follows principle of superposition. Now there are two things that I think you might be confused of. One is conservative force, another is principle of superposition. Principle of superposition, I am telling you here. The formula that we have written is for two masses only. Now, what if I say there are three masses like A, B, C, and you have to calculate force on A? Who is your object at which you are trying to calculate the force is at A? Your intention is to calculate force at A. So what it B will exert force, C will also exert force. Then principle of superposition says that net force at A is the vector sum of forces at A due to B plus due to C. This is the real story. This is the vector sum. Now, one thing to be sure, because before moving further, each and every term should be clear. Can anyone write what is the meaning or how you will write FAC? How you will pronounce it FAC? How you will pronounce it? Can anyone answer? How you will pronounce FAC? It's not like FAC. Force on what? Due to which? Force on A due to C. Very good. And its direction will be along A to C. That's what I have told you. Direction will be from A to C. I have mentioned the arrow. Okay. So now clear. Do you know what is conservative force, or should I move further? Because this is a part of work, energy, power chapter. This is a part of WEP chapter, work, energy, and power chapter. So if you want me to discuss right now, I will discuss. Otherwise, wait for that moment. Okay, moving further. So there is a very basic, simple concept test. Okay. Question says, two particles of equal mass m go around a circle of radius r under the action of their mutual gravitational attraction. The speed v of each particle. The question is looking very simple, but it's not that simple actually. What's happening here? There are two masses, each of same mass, like suppose m and m. Clear? They are saying go around a circle of radius r, and this system is saying, the question is saying the speed v of each particle. That means both are revolving in a circular path. Both are revolving in a circular path like this. If the circular path is not very much circular, then you can assume it to be circular. So these are the two masses, and they all or the both are revolving in a circular path. What is the radius? They are saying radius is r. If one is going in this direction, then another one must be going in this direction, and they will move like that. They will move like that. Now, one thing to be sure, listen to me, this is another concept other than the question. When two bodies like this, two bodies are moving in a circular path, then where will be the center of this system or this circular path? The center lies at the center of mass. I hope that someone of you might get confused, but listen to me again. I'm repeating my sentence. When two bodies revolve in a circular path with mutual force or mutual gravitational force, then the center of their circular path is at their center of mass. What is center of mass? However, in this question, the center of mass is or will be at the center or the midpoint of the two masses. Why? Because these are the two masses of equal mass. If let's suppose this will be 2m and this will be m, then their center of mass will be not at the midpoint of the line, will be near the heavier mass. So what would have happened? This mass will revolve in this R1 radius and this small m will revolve in this R2 radius. That means there will be two different circular paths. That's a complete different story. But you should know that why I am taking the center at the midpoint. Is it clear? Where will be the center? At the center of mass. But in this question, both the masses are similar, so center of mass will be at the midpoint. So now, the question remains very simple now. Whenever a body revolves in a circular path, there must be a centripetal force. And this centripetal force is nothing but if you can say that both these masses will attract each other. So this is going to be the centripetal force or gravitational force. So what I can write here, gravitational force will provide centripetal force. So you can say that centripetal force is provided by gravitational force. What is the gravitational force between these two masses? You can say G product of masses is m square divided by the separation between the two masses is what? R is the radius, then separation will be 2r. That means 4r square. If I square it, you know the formula, na? G m1 m2 upon r square. This force is the necessary centripetal force. What is the formula for centripetal force? That is mv square by r. Now you can cancel things out. R cancel the power, m cancel the square. So here you can write v square is equals to g m over 4r. So if you take v, what you will get? G m over r under root. And square root of 4 is 2. So this is our answer. Now tell me one thing. Is the statement of the question clear? Is the answer or solution is clear? Whenever there is a circular motion, now what you learn from this? You can learn whenever there is a circular motion, there must be a centripetal force. And this centripetal force will be provided by some other force. Here in gravitational force is this source of centripetal force. But if these are the two charges, then the centripetal force will be provided by the electrostatic force. So only these things will be required. So which option is correct out of these? Option A is correct. Why C? I think there is only two now. So option A is correct. You can see. Clear now? Okay, moving further. Acceleration due to gravity. So first of all, what is acceleration due to gravity? If I talk about one thing to be remembered, and everyone should know that what is gravity? Gravity is the force or the gravitational force exerted by Earth on any object or any mass. That means the gravitational force is a universal force, but this force is called as gravity when it is exerted by Earth. When the source of the force is Earth, then it is called as gravity. Now, one thing is clear. Now, let's suppose I am saying that this is our Earth. This is our Earth. Clear? And generally, what we assume that mass of the Earth is me and the radius of the Earth is re. Clear? Two things are clear. These are the mass and radius of the Earth. Again, one thing, there is a object, a very small object of mass m is placed at the surface of the Earth. Is placed at the surface of the Earth. Now, what will be the force? You can say that force or the gravitational force will be equal to G into product of masses, that is me into m, divided by separation square. If you see this object, I have taken very small or point object. So the distance between center to center, I have told you now the distance we take is from center to center. So this distance is nothing but the RE. So it will become RE square. This is force, and this force is known as gravity. Now you can say that if I talk about acceleration, from the Newton's second law, you know that F is equals to ma. So A is equals to F by m. Clear? So acceleration due to gravity, I am writing it A, but you all know that acceleration due to gravity is denoted by G. So can I use this term G? Is it nothing but the acceleration? I am denoting, or we are denoting it with this symbol G is equals to force by mass. Now if you put the values, so G will become, force is what? Gmem divided by Re square. This is force divided by mass. And m will cancel out. G is equals to Gme over Re square. So this is acceleration due to gravity. And you should remember, because this relation is used many times, you should remember always. G is equals to Gme over Re square. Clear now? Moving further. Now, what we have assumed here is the mass or the small body is placed at the surface of the Earth. There might be situation when it is not at the surface, it is at a certain height. So in that case, what will happen? So now our next heading is variation in small g, variation in acceleration due to gravity. There might be a few factors on which this depends. So let's suppose one reason is due to height. That's what we are talking about. Let if the body is taken up to a certain height from the surface of the Earth, it is at a height h. Mass of the body is m. This is our Earth. You can say Earth, that means radius is re, mass is me. Now what you can see, the variation in g is will be equals to g dash is equals to g. This is original gravity. 1 minus 2h over re. You should remember this. You should remember this. G dash is equals to G 1 minus 2h over re. H is the height from the surface. Re is the radius of the Earth. The conclusion is, as we move away from the surface of the Earth, gravity decreases or acceleration due to gravity decreases. Try to note it down. Now, next thing. This is the thing for height. Now, what if I put the mass or bring the mass inside the Earth? Now, next case is due to depth. Due to depth. Now, what will happen if I put the body at a certain depth from the surface? Let this depth is h. Again, the relation will be g dash is equals to g 1 minus h over re. You can see that the difference between two cases due to height, it was 1 minus 2h over RE. This is due to height and this is due to depth. So there is only one difference in the two, and that is the difference of this term 2. So you can easily remember the relation. If you have remembered one relation, then second is very easy. Is it clear? So based on this, there is a very small question on your screen. Now there is one more variation, that is due to the rotation of the Earth. Now what if I say Earth rotates with some angular velocity? Let's suppose angular velocity is omega. Then what will be the, you should again remember this. What will be the variation in the G? New acceleration due to gravity will be G minus omega square RE cos square phi. This phi is the latitude at this point. This phi is the latitude of that point where you are interested to calculate gravitational acceleration due to gravity. Now, one thing again, if you see this angle phi is, let's suppose body is here, and this phi is taken from the equator. This phi is taken from the equator. Now, listen to me. If I talk about at the poles, if body is at the poles, then this phi will become 90. Can you see that? So what I'm saying, at poles, phi will be 90. You can see that. If phi is 90, then cos phi is 0. Because cos 90 is 0, so G dash will be equals to G. What does it mean? The simple meaning of this is, at poles, there is no effect of rotation on G. Is the statement clear? This is the punchline that you should remember, that at poles there is no effect of rotation of the Earth. It will remain the same. Now, if I talk about at the equator, if I talk about at equator, can you see that if equator I talk about, then mass will be here. Then what will be the angle? This angle phi is made with the equator now. So this angle phi will become 0. Phi will become 0. And if phi will become 0, so you can say that G dash is equals to G minus omega square RE, because cos 0 is 1. Can you see that the maximum effect is there? Because maximum value is decreased. So you can again write, the conclusion is at poles, effect of rotation is maximum. Now these are the punchlines. The effect of rotation is maximum at equator and minimum at poles, or it you can say no effect. Moving further. Okay. So everyone should solve this question. Do you have your pen with yourself? Pen, paper, anything, so that you can solve? Say at least yes, so that I can see that how many of you are listening. Otherwise, it's like that everyone is not listening. Kind of you have joined and not listening. Okay. You only one person is listening from YouTube. The person who is listening, say at least yes. Very good, Logesh. Okay. So everyone has pen with you and pen and paper. Okay. So that's good. Really good. Sanskruti Gaikwad is also listening things. Okay. So now Actually be active in the class. So it will make a environment of the class. Now you should feel very good. Nirame is also present from YouTube. Okay, so now we will solve this question. The question says the acceleration due to gravity. 1, 2, 3, 4. That's a different name. At a height 1 kilometer above the earth, Sushant, is the same at a depth d below the surface of the earth. The question is very simple. Let's solve it. You should remember the relation. Let's suppose this is the earth. And there is an object that is saying at a height 1 kilometer above the earth. So at a height 1 kilometer, clear? And let's suppose at a depth d below the surface. So these are the two situations mentioned, and they are saying acceleration due to gravity at both these points. Let's suppose this is point A and this is point B. At both these points, acceleration due to gravity is same. Question is saying that. Now, they are saying that acceleration due to gravity at A is equals to acceleration due to gravity at B. Can you see that at these 2 points we have derived the relation? What is the relation that we have derived? At A, that means at a height, what we know that G dash is equals to G 1 minus 2H over RE is equals to G 1 minus this, let this is H, this is D, 1 minus B over RE. You remember this relation, only the difference in this two term. Now, if I put the values, first of all, this G will be cancelled. Clear? Another thing that you can see, if you can see, this 1 will be cancelled. So what will happen? This minus will again cancel. So what will happen? 2H over RE is equal to D over RE. So RE will again cancel. So what it will be? D is equals to 2H. What is H given? H is given as 1 kilometer. So D will be 2 kilometer. You could have solved this question. You could have solved this question. Very good. I think someone of you or few of you might have solved that. Okay. Is it clear? So which option is correct? Option C is correct. Clear? Moving further. Gravitational field. While explaining the gravitational field, just tell me one thing. Is that everything that we are studying here, is it going to be helpful or is it helpful in any manner to you? Or what you need extra to make you successful, to make you achieve the goal that you have decided? You can tell me. So now what is gravitational field? Again, listen to me. This is again a very important concept. What I am saying, let's suppose this is a mass m, and at a certain distance there is another mass small m. Till now what we have studied, that this capital M will exert force on that. This capital M will exert force on that, and we know the formula, how much force it will exert. But the question is that this or these two bodies are not in contact. These two bodies are not in contact, then how could they exert force? Because if you want to exert force on your friend or on table or on anything, you need to touch that. You need to push or pull kind of thing. But now these two bodies are exerting force without any physical contact. So such kind of forces are known as non-contact forces. What they are known called as non-contact forces. So if there is a non-contact force, then there must be a phenomena to explain how it can exert force. So that phenomena, that theory which explains non-contact forces is called field theory. So field theory says that any mass, I'm telling you what is gravitational field, that any mass placed in the surrounding creates an environment, creates an environment. Anyone which comes in that environment will be attracted towards the mass, will be attracted towards the mass. So gravitational field is a phenomena which explains the non-contact force theory, and how it is given as, it is denoted by E and is given as force per unit mass. This is the source of the field. This is the mass that is placed. Then how much force it exerts on a unit mass is known as gravitational field. From the relation, you can see that this is not the solution thing. From the relation, you can see the unit will become, what is the unit of force? You can say Newton. What is the unit of mass? That is, you can say kg. What is the unit of gravitational field? Newton per kg. Moving further. One more thing. Gravitational field is a vector quantity. So it must have a direction. It must have a direction. Then direction of this field will be towards the source mass. Towards the source mass. Now, can you identify the source mass? It is given in the question that for which mass you want to calculate the field. So it will be towards the source mass. Remember this. Now, for example, in this question, if I talk about what will be the direction of field, let's suppose this is source mass O, let's suppose this is A and this is B. You want to calculate or find the direction of field at B. Who is creating this field? This M is creating the field. Then direction of field will be towards the mass. Towards the mass, that means B to A. B to A. Moving further. Another thing is gravitational potential. Gravitational potential is, you can say, okay, listen, read the definition. I am telling you a thing here. Let's suppose this is a mass, and you want to calculate the potential at this point. Let's suppose this is point A. Then how is gravitational potential defined? It is defined as work done in moving a unit mass, work done in moving a unit mass from infinity to that point. From infinity to that point is called gravitational potential. This is what mentioned here. Bringing a unit mass from infinity to that point is known as gravitational potential at that. So that means if you bring a unit mass from infinity to that point, this work done is equals to gravitational potential and is denoted by V. How is it denoted? Denoted by V. Clear? The definition thing is clear. Okay. Moving further. Gravitational potential due to a point mass. What will be the value of potential for a point mass? Let's suppose this is a mass M and you want to calculate the potential at this point A, which is at a distance R. So what will be the potential value? Minus GMM over R. I think you have remembered the relation. You from the class 11th, you have studied that. So there is no problem with that. V is equals to minus GM over R. The important thing which is to be remembered, which is to be learned by you is this. That is potential gradient. That's the most important question. What is it? The relation dV is equals to minus E dot dr. I will explain this in detail. First thing here, the negative sign. The negative sign tells potential decreases in the direction of field. It says potential decreases in the direction of field. Now again, all other terms if I explain, dV is the small change in potential, dV is the small change in potential, dr is the small displacement. That means if you move from one point to another, the change in potential will be E dot dr. Now, if you want to calculate it for a larger distances or larger displacements, then what you should do? You should integrate it. dV is equals to minus is already there E dot dr. This is the relation. Now, the type of question that is being asked from it, we should understand that as well. Listen, there are two type of questions that may be asked from it. One is they will give you the field and ask you the potential. They will give you the field and ask you the potential. Another thing, they will give you the potential and ask the field. Two things are clear. That means they can give you either potential or field and ask the another thing. First thing, or first application, to find potential. If field is given, listen to me. I will give you an example of that as well. But first of all, you should remember this relation. Generally, in vector form, field is given as Ex I cap plus Ey j cap plus Ez k cap. Don't worry, it may look like something very horrible or terrible, what you can say. But if I talk about example, how this field will be, the field will be something like that 4 I cap or something 4x I cap, 2y j cap plus 3k cap. It will be something like that. So the component which is attached with the I cap is known as Ex. The component which is attached with j cap is known as Ey and similarly Ez. This is the general form. It is given as like that, and you should compare it with this equation. And dr is the displacement. So dr is somewhere like dx I cap, dy j cap, and dz k cap. Don't worry, I know that it's very difficult for you. So how the potential will be? It will be dv is equals to minus. If I put this value of E and dr, then it will become Ex dx plus Ey dy plus Ez dz. This is how you can calculate the potential. And don't think that this is an integration thing and they will not ask for the NEET student. It is a very common question, and every one of you should be aware of this thing because they will ask you the very simple integration thing like x square. So these type of integration you should know. So don't worry, don't uh, exclude this topic due to the integration part only. Another thing, first thing is clear, to find the potential if field is given. Another thing that we will study here, or the second point, to find field if potential is given. This is the question that I have explained you in this in the exam that was held on 30th March. I have explained you this type of question. How is it? Field in the x direction, field has three components, x, y, and z. Field in the x direction will be negative of partial differentiation of v with respect to x. Field in the y direction will be negative of partial differentiation of v with respect to y, and Ez will be negative of partial differentiation of v with respect to z. Now there is another term that you should aware, that what is the meaning of partial differentiation? When you are differentiating it with respect to x, then y and z are constant. Then y and z are constant. Remember this. Clear? Okay. And similarly, if you are talking about with respect to y, then which are constant? X and z are constant. Moving further. There is a question. Now tell me which application you should use, first application, or is it based on second application? On which application it is based? Field is given first. Very good. Field is given and they are talking about potential. Okay. So how would you calculate it? You know the relation. dV is equal to minus is already you need to put, and then integration Ex dx plus integration Ey dy. Can you see there is no z term, only x and y are there. So I will not place Ez and dz. Is it clear? Now you need to put the values. It is very simple. That is integration of dV is equal to minus is already there. What is the value of Ex? Can you identify from the question, from the equation? Ex is the what? Component of I cap. That is minus 2x dx plus Ey is what? 3y square minus 3y square dy. Clear? Again, can you see that minus is already there? Now, what will be the limit? In terms of x, they are talking about from 0. They have given us potential at 0, 0 and moving to 1, 2. If in x direction, you can see initial component is 0 and finally we are moving to 0.1. So that is 0 to 1. In y direction, you can see we are moving from 0 to 2. 0 to 2. Clear? So what it will be? The integration of minus 2x will be minus is already there. If you integrate it, it will become x square. Do you know the integration thing, or I will explain it? Okay. Someone of you might have forgot that how to integrate. Okay, which pen I was using, like this. 2 is a constant, write it as it is. While you integrate, increase the power by 1. So x has a power 1, you can increase it x square by 2. Limit is 0 to 1. Plus, or you can say minus 3. It will become y cube by 3. Increase the power by 1 and divide by the same power. Limit is 0 to 2. What it will be? 2 and 2 will be cancelled. 3 and 3 will be cancelled. Can you see that minus is already there outside? It will become 1. This is 8. If you put the upper limit, 2 to 8. So it will be minus 9 and minus minus cancel. That is 9 volt. This is what you get the answer, 9 volt. So which option is correct out of these? 5790. Option D is correct. So this is very simple thing. Field is given, just integrate it like that and put the limits and you will get the answer. Clear? Moving further. Very good, Veena. You have answered. Moving further. Gravitational potential energy, another very important topic. Very important. Whenever I mention that, some one of you might think that, sir, for every topic you are saying the same thing. It's not like that. Let's suppose I am telling you how to write the gravitational potential energy, or what is the definition. Definition says work done. Listen to me, I'm not writing it completely. Work done in assembling a system of masses is called gravitational potential energy. Is called gravitational potential energy. Clear? Now, if I talk about, let's suppose there are two masses, or in fact, I will write it for three masses directly. There are three masses M1, M2, and M3. M1, M2, and M3, and there is a separation of R1, R2, and R3 between them. This is point A, this is point B, and this is point C. And what we need to do, we need to write the gravitational potential energy of this system. What you should do, listen to me very carefully. First of all, make the pairs of two masses. Make the pairs of two masses. Then, can you see that? How many pairs of two masses are there? One is a pair of AB, one is a pair of BC, and one is a pair of CA. Can you see that? There is a pair. Out of these three masses, you need to form the pairs. So pair is, one is AB pair, A and B, two masses. B and C is a pair. C and A is a pair. Only three pairs are there. Then again, what you should do now, the gravitational potential energy is equals to, put the negative sign and write G. I am telling you the trick. Now start the bracket. Now again, what you should do, multiply the charges of a pair, like A and B is a pair. So multiply the masses here, so that masses are M1 and M2, and divide them by their separation. The separation between M1 and M2 is R1. Very simple. Now plus another pair is BC. Product is M2, M3. Divided by the separation is what? R2. Plus another pair is AC. AC is what? M3, M1. Divided by the separation is R3. This is the method how you should write gravitational potential energy. What you do, minus and G, put outside, start the bracket, multiply the charges in a pair, divide by their separation. Product of charge divided by separation, product of charge divided by separation. What about the square for the separation? Okay. The square, you are talking about this square, no? Or the triangle shape, you want a square shape. Which square you are talking about? R square, no. When you are writing the gravitational potential energy, it's not a square thing. It's only R. Only divide by the separation, not the square. The square is used in only two terms. One is gravitational force, another is gravitational field. Only in these two terms, square will be there. Otherwise, it will not be a square term. It will be a linear term. Clear? Okay. So if I talk about, can you write the potential energy of this system? It is your homework. How many charges are there? 4. A, B, C, D, and this is a square of side small a. How many pairs will be there? Can anyone tell me how many pairs of charge? Pairs means combination of two charges. Pair is formed by two charges. How many pairs will be there? Six. Very good. Very good. AB, BC, CD, BA, and two are the diagonals. That is AC, and another diagonal is BD. So six pairs are there. Product of charges divided by separation. That's all. Clear. Now, one more point that I need to tell you. What is the meaning of negative sign here? This is very important question, and you should remember what is the meaning of negative sign in potential is whenever you see potential energy and there is a negative sign, then you should conclude that there is a attraction force between the particles. Between the particles of the system, there is what? There is an attraction force, or in another words, you can say that the system is bounded system. So what is the meaning of this negative sign? It is a bounded system. Bounded system. And the forces are attractive in nature. Bounded means it is, uh, bound means, you know, the bound. Bound means banda hua. It is something banda hua kind of thing. Okay. Negative sign, you know that. Okay. This thing you should do in homework. Very simple question. Now I will move further. Escape velocity. Let's suppose this is our Earth and a mass is placed here. Then what is escape velocity? The minimum velocity required for an object at Earth's surface so that it just escapes the Earth's gravitational field. The definition thing might confuse you. Listen to me again. Look at me. You are on the Earth's surface. You have a ball in your hand, and the minimum initial velocity that you should give it so that it will not return, back is known as escape velocity. Is known as escape velocity like this. You have thrown it and it will not return back. If it will not return back, then it is known as escape velocity. Now, what is the formula for that? Formula is written on your screen. If you calculate this value for Earth's surface, it will be approximately 11.2 kilometer per second. I think this is a very famous term. And in class 11, we discuss a lot about it. Can you throw it? Who can throw it with that speed? Actually, nobody can throw it, any particle with that speed. Okay. So what is UE? 2g me over RE. Here, listen to me one thing very carefully. This relation is written here for Earth. For Earth. If we are throwing the ball from some other planet, then this mass and radius will be replaced by the mass and radius of that planet. Suppose you are on moon, then what mass you should put here? You should put the mass of the moon and radius of the moon. And one thing to be noted here, the mass of the ball is not coming in the escape velocity picture. The formula for escape velocity is independent of the mass of the body that is to be thrown. That's a punchline. If someone says you, the escape velocity, listen to me. You have a ball of mass 1 kg and you throw it to escape that. So what is the escape velocity? Let's suppose it is 11.2 kilometer per second. What if someone says I am throwing a ball of 2 kilogram mass? Then should I throw it more quicker to escape the Earth? You will say no. It is independent of the mass of the body which is to be thrown. Clear? Moving further. There are few punchlines. On which parameter escape speed depends? One is it depends on the mass and size of the planet. It depends on the mass and size of the planet. Another thing, position from where the particle is projected. On these two parameters, escape speed depends. On which it does not depend. Mass of the body which is projected, that I have told you, and angle of projection. If you throw it vertical, if you throw it something like at some 45-degree angle, it doesn't depend. It doesn't depend. These are the questions which is very important for your NEET exam. I put the questions of NEET exam in terms of punchline so that you can easily remember those. Okay, so this is the question that we are going to do. After that, we will end the session. Two things will be remaining after this. One is Kepler's law, which is to be remembered by you. I don't do with I don't have to do anything with that. Now another thing is satellite. You can remember the formula. Now the question says the escape velocity from the Earth's surface is v. Clear. The escape velocity from the surface of another planet. Listen, they are talking about some other planet having a radius 4 times that of Earth and same mass density is. That's a very good question. Now, for Earth, if I write about for Earth, let's suppose mass of the Earth is m and radius is r. Clear? So for Earth, you know that formula that escape velocity is v is equals to root of gm over r. You can check the relation if it is right or wrong. Root 2 gm over r. It's 2 gm over r. This is the for Earth. Now, if we talk about for some other planet, for other planet, if I talk about, now what is mentioned, the radius is 4 times. That means let's suppose its radius is r dash, it is 4 times of radius of Earth. That is given. And now another thing, they are saying that same mass density is denoted by rho. Okay. Mass density is denoted by rho. Now what I'm saying, that size of the other planet is larger than Earth. Then can you see that its mass will also be more because density is same? Because density is same. So its new mass, or you can say its new mass, m dash will be more than that of the Earth mass. So that will be rho into its volume 4 by 3. You know the formula, mass equals to rho into volume, density into volume. So 4 by 3 pi, and radius is what? 4r cube. Clear? And for Earth, we can write mass of the Earth as V is equals to root 2g, and mass of the Earth is, let's suppose density is of both is rho, that is rho, into what is the volume of Earth, that is 4 by 3 pi r cube, and r is already there. So V can be written as, if you can see, r will be cancelled, r square. So that will be root of 8g rho pi r square by 3. You can see that. Now, we know the m dash, we know the r dash. Now we are putting the values for v dash. New escape velocity will be root of 2g m dash by r dash. Now put the values. 2g m dash is what? Rho 4 by 3 pi 4r, that means 64r cube divided by 4r. We know the value of v, we know the value of v dash. If you want to calculate the new velocity v dash, then you can divide these two equations. Let it be equation number 2, let it be equation number 1. We can divide these two equations and we will get our answer. Sushant is saying 4. Sushant is saying 4. 4 means option 4 or 4B, you are saying. You can divide these two velocities and you will get your answer. Whatever it will be, you can cancel. You can see that a lot of things will cancel. 2, 0, 4 pi and 3, everything will be cancelled. So you can easily calculate the answer here after dividing. Because it's already over, I am not going to do that. For that, this is the formula you should remember for orbital velocity, and this is for energy. Only these two relations you should remember. After that, there is Kepler's law. So we will not discuss Kepler's law. So energy thing you can remember. So I am ending the session here. Bye everyone. Thank you.